Hi! Within this class, we are going to acquire a better understanding of the SDX framework. First of all, it's worthy to mention that the SDX is not just a framework, but it's a family of development environments for system and software engineers. Nowadays, software is at the foundation of application specification and development. No matter the specific domain the application is targeting, genomics, more in general medicine, gaming, entertainment, physical simulation, scientific computation, telecommunication, most products available today are started to be studied and designed as software model or prototype that needed to be accelerated and executed on an hardware device. From this starting point, the software engineer is tasked with determining the execution device to get a solution to market and to achieve the highest possible degree of acceleration possible. One traditional approach to accomplish this task has been to rely on processor clock frequency scaling. Well, unfortunately, this solution is just no longer working, or at least, it's not the most efficient way to achieve the highest possible acceleration, to meet optimal performance. And this is one of the reasons why we are assisting to a shift towards the adoption of multi-core and heterogeneous computing devices. These architectures provide the software engineer with the possibility to more effectively trade off performance and power for different form factors and the computational loads. The one challenge in using this new computing architecture is the programming model of each device. This is exactly the kind of changes Xilinx is trying to deal with by providing SDX. SDX enables developers with little or no FPGA expertise to use high-level programming languages to leverage the power of programmable hardware with industry-standard processor on or off-chip. The main three development environments in SDX are the SDNet development environment, the SDSoC development environment, and last but not least, the SDXL development environment. As we can also find on the Xilinx website and the documentation, the software-defined specification environment for networking, or SDNet, in conjunction with Xilinx all-programmable FPGAs and SoCs, allows for the creation of softly defined networks, a technology dislocation that goes well beyond today's software-defined networking architectures. Softly defined networks support SDN functionality, while also allowing for game-changing differentiation through software programmable data plane hardware with content intelligence that dynamically collaborates with control plane software while addressing the performance, flexibility, and security challenges of modern content-oriented networking. Now, what about SDSoC and SDXL? On one hand, the software-defined system-on-chip, or SDSoC, is an Eclipse-based integrated development environment for implementing heterogeneous embedded system using the Xilinx Zynq 7000 all-programmable SoC platform. SDSoC provides a developing environment where software engineers and/or system architect can experience an embedded C, C++ application development combined with an easy-to-use Eclipse IDE and comprehensive design tools for heterogeneous Zynq SoC development. This environment includes a full system optimizing C, C++ compiler that provides automated software acceleration in programmable logic combined with automated system connectivity generation. Therefore, this application programming model should be intuitive to software engineers. The application designer has to write his or her application in C, C++, and she or he just have to identify a target platform and a subset of the functions to be translated into hardware. Within this context, based on the user specification, the SDSoC environment performs program analysis, task scheduling, and binding onto programmable logic and embedded CPUs, as well as hardware and software code generation that automatically orchestrates communication and cooperation among hardware and software components. That means that all the, let's say, tiny details on how to implement the application as a combination of hardware and software elements to realize the complete embedded system to be implemented on a Zynq device are carried out by the SDSoC system compiler, and not by the designer. Well, this to me is definitely looking like a game-changing solution. On the other hand, the software-defined development environment for acceleration, or SDXL, is a kind of similar to SDSoC, but it's targeting a completely different applicative domain. With SDSoC, we are interested in designing embedded solution. And please note that when I'm saying embedded solution, I'm not referring to system implementation that are easy to be designed. I'm just referring to a specific applicative domain. While with SDXL, we are targeting, as an example, data centers, distributed system, heterogeneous high-performance computing infrastructures. Within this context, we are looking for better performance per watt for data center application acceleration leveraging FPGAs. SDXL combined the industry's first architecturally optimizing compiler supporting any combination of OpenCL, C, and C++ kernels along with libraries, development boards, and the first complete CPU-GPU-like development and runtime experience for FPGAs. Designers using SDXL are allowed to create FPGA-accelerated design using C, C++, OpenCL, or RTL programming languages. This is simply awesome. With this developing environment, we can really gain the best out of the underlying architecture while gaining also to support for the runtime, and at the same time this can be done by using our preferred programming language. Well, this is really a first attempt to create a comprehensive ecosystem to ease the design of an FPGA-based system. Now, going back to the overall SDX environment. Even if it's true that it is composed also by the three above-mentioned developing frameworks, we are more kind of considering SDX as the combination of SDSoC and SDXL, and this is also true from a software installation perspective. The SDX environment software release consists of the SDSoC development environment and the SDXL development environment that are, as we know, targeting different types of designers. They are both installed together, but are licensed separately. It is also interesting to mention that also the Vivado design suite is installed with the SDX environment for programming the device and for custom hardware platform development. This is definitely interesting, because it is again making the point of a coherent ecosystem in Xilinx. The differences, as we know, are in the fact that SDSoC is targeting embedded designers, while SDXL is looking more towards distributed data center cloud system designers, but both these designers can be interested in designing custom hardware. More precisely, the Xilinx SDX tools, and now we know that from the installation perspective they are including SDXL environment and the SDSoC environment, and Vivado HLS, provide an out-of-the-box experience for system programmers looking to portion elements of a software application to run in an FPGA-based hardware element, and having that hardware work seamlessly with the rest of the application running in a processor or embedded processor. The out-of-the-box experience will provide interesting and, let us say, good enough results for many applications. However, this may not be true for you. You may be looking for better performance, data throughput, reduced latency, or to reduce the resource usage. That means that you may need to optimize the hardware logic to obtain the best of your hardware implementation. In this case, certain attributes, directives, or pragmas can be used to direct the compilation and synthesis of the hardware kernel, or to optimize the function of the data movement between the processor and the hardware logic. This is concluding this class. As we know, this course is not focusing on embedded application, but is more focusing on distributed heterogeneous cloud infrastructure. Therefore, we are not going to provide more information about the software-defined system on-chip environment, but we are going definitely to dig more into the details on how to use Xilinx SDXL, providing you also with working examples, and on how to bring your solution to life by using the Amazon EC2 F1 instances.